All right, so I'm going to look at inverse functions here. So inverse functions are things that kind of cancel each other out. All right, you already know about multiplication and division, how those are inverse operations. Square root and squaring, those are inverses of each other. So two inverse functions, basically it's like when you combine them using function composition, they end up reversing each other. All right, that's what's going to happen here. So f of x and g of x, these are inverses of each other. I'll go in on the next video. I'll show you how to actually find an inverse function. But you can probably already tell why these two might be considered inverses of each other. So f of x, this is like my original function. The x is being multiplied by 3 and then subtracted by 1. And on the g of x function, x is being added by 1 and then divided by 3. So it's these same two operations up here, but it's the inverses of them, and they're happening in reverse order. Okay, so that's kind of what's should kind of give you a feel for what inverse functions look like. All right, they're just inverse operations, sorta. All right, let's go ahead and work an example here. I'm going to evaluate g of f of 10. All right, so f of 10, let's see here, 3 times 10, that's 30. 30 minus 1, that's going to be 29. So I get g of 29. And then for g of 29, I go to my g function. It'll be 29 plus 1, that's 30. And then 30 divided by 3. Well, that's 10. And that was the idea here, is that g and f, because these two are opposites of each other or inverses, when you perform one function on the number and then perform its inverse on that, they end up kind of canceling each other out, and you're left with whatever you started with. All right. So let's say I wanted to find g of f of 7. Well, I actually don't have to do any math here. Because I know that g and f are inverses of each other, I know that they're going to wipe each other out. And so that's going to leave me with 7 in the very end. In general, if you wanted to show this, and this is like a test for how to prove whether or not two functions are inverses of each other, is to actually compose them in general. So I'm going to perform here. I'm going to do g of f of x this time. So I'm going to replace f of x with my 3x minus 1 up here. So it's g of 3x minus 1. And so to simplify this, I'm going to go up to my g function right there and just replace that x with a 3x minus 1. So what I end up with is 3x minus 1 and then plus 1, all of that over 3. Okay. The negative 1 and the positive 1 just cancel each other out. I can drop parentheses. And so I'm left with 3x over 3. The 3's cancel each other out, and I'm left with x. So in general, the g function just completely cancels this f function, and so I'm left with whatever I started with whatever my original input was. All right. So when you compose two functions which are inverses of each other, they cancel each other out, and you're just left with whatever your original input is. All right. The notation here, I know I've been using g of x to represent the inverse. The actual notation for a function's inverse. So if I say that f of x is equal to 3x minus 1, to represent its inverse, the notation they use is they use a little negative 1 there. So this is original f of x. This would be f inverse of x, right? and that's equal to the x plus 1 over 3. So to say that, to say this function composition sentence again, but using this notation, this is the more common, is I could say f inverse of f of x. So I'm composing a function with its inverse. What happens is these two just cancel each other out, and you're left with x. Okay. So if you ever see something like f inverse of f of 2, well, these two are just going to cancel each other out, and you're going to be left with 2. And I know I've been writing it as the inverse of f of x, but it holds true the other way. Like if you do the original function composed with the inverse function like this, it's also going to work out so that these two just cancel each other out, and you're left with x as well. So the order doesn't matter, and the order in which you're composing them doesn't matter. Okay. So when you compose two inverse functions with each other, they cancel each other out. Do one more here. All right, so I'm saying here, actually, let me just erase this g of x here. These are inverses of each other. We'll go through on the next video and show how to actually find that. But let me call this f inverse. Okay. So what I want to look at, let me start by just plugging in a number. I'll look at f of f inverse of, don't want to use 2. Let me pick out a good number here. Oh, maybe it's not going to matter. I'll do 3. 3 will work out. Yeah, this will be a number that plays nicely. So I got to do f inverse of 3 first. So I'm going to go to my f inverse function. This is going to be 3 squared, which is 9, and then 9 plus 1, which is 10, and then it's going to be 10 divided by 2. So what I wind up with is 5. Okay. Now to work out f of 5, I go up to my f function. It's going to be square root of 2 times 5 minus 1. 2 times 5 is 10. 10 minus 1, that's 9. So I get the square root of 9, which turns out to be 3. And that's what I expected should happen, right? When I'm composing a function and its inverse, they cancel each other out, and you're just left with what you started with. We'll do the general case now. So I could do this 2 ways. It doesn't matter the order. I'll do f inverse of f of x. I'll try it like this. So this is going to be f inverse of the square root of 2x minus 1. Okay. So what this means is I'm going to go up to my f inverse function here and replace that x with whatever is right here. So this is going to be parentheses, the square root of 2x minus 1. All of that stuff squared, all right? And then plus 1 over 2. We'll work this thing out here. When you have your square root and your squared, those just cancel each other out, and you get 2x minus 1 plus 1. Okay, the 1's cancel each other out, and then you're left with 2x over 2, so you're just left with x. All right, and that kind of proves that these functions are inverses of each other. Nice. Oh, and I guess I should have mentioned, the way you can kind of, to get a feel for it, we can kind of tell just by looking. You see how x is being multiplied by 2, subtracted by 1, and then square rooted. Well, down here you get all those inverse operations. X is being squared, which is the opposite of the square root. It's being added by 1, which is the opposite of that. And it's also being divided by 2, which is the opposite of multiplying by 2. All right, that's good for this one. The next video we'll look at how to actually find inverse functions.